MIT partners with industry to address problems of interest, and a recent example is one with the Boeing company, with which we've had a long relation for a long time, but that particular problem was new in that it has not been looked at from an academic perspective very much. And that particular problem is lightning strike protection for aircraft. That's a very important problem in that from a practical perspective, from a manufacturing perspective, it is very expensive to protect aircraft against lightning. And given the changes from metal or aluminum frames to composite frames, that's a problem which is gaining increasing importance. So for that particular problem, as I said, there is very little expertise around the world, and in particular we had no expertise at MIT, but it was because of this partnership that Boeing approached us and asked us to put a team together to address that particular challenge. And we've been able to get a number of faculty interested, and I'm part of that group. And we've been studying that problem for a couple of years now, and we are going towards our first important results, potentially leading to even a patent. And we think this is a good example of collaboration from industry and university. It's a problem that had not been brought up by industry. It would be very unlikely that we would have approached it from an academic perspective. And on the other hand, I think industry requires the level of expertise that is available at MIT to tackle these challenges. Other problems that we are looking at, and again, that may not be, that's a problem which is perhaps more loosely related to aerospace. We've been using the techniques we've developed over the years to design products and devices which may be a little bit outside the aerospace field. And in this particular case, I'm referring to the design of photonic crystals and multifunctional materials, and the design of photonic crystals. These are structures which are built at the limit of manufacturing, and the challenge there is to be able to computationally prototype these devices and predict their behavior, subject to the constraints of being able to manufacture them. So that's a very complex problem, because on one side you have some physical requirements, on the other side you have some manufacturing constraints, and you really want to be able to find the best solution that is going to be buildable and that meets your physical specs. A lot of our research is funded by the Air Force, and the Air Force has a broad range of needs. Some of them have to do with directly what we would consider aerospace, but also has needs having to do with materials, with logistics and other applications. And in this particular area, in the particular area of materials, we've been able to use some of our simulation methods to design photonic crystals, which are structures that exploit the flow of light, and they are built at a very smaller scale. And one of the challenges there is to be able to build the structures that meet certain requirements and satisfy some manufacturing constraints. And here is where simulation has proven to be quite powerful. One of the areas of interest is hypersonics, and this is an area which is becoming even more important with increased access to space. We are seeing a number of not only government agencies but also private companies accessing the space, and with the increased frequency of flights, we expect that there will be a strong interest in understanding these flows better, where there is still a lot of unknown. And here is again where numerical simulation can help us, in particular because getting experimental data or getting physical data is very difficult in such conditions, and we rely heavily on the ability to simulate those flows in the computer. One of the things that I think we do very well at MIT is the ability to engage whether with government agencies such as NASA or the Air Force, or even industry, to address long-term problems, long-term challenges. And For us, the most successful partnerships are those in which we work together to define the problem and to look for approaches to address this particular problem. These relationships are often long-term, they involve multiple years, but in our experience, this is what we are better suited to do here at MIT. This is what we do well. Look at problems, analyze them, extract the important features and come up with the strategies that allow us to come up with effective solutions.